Ever wondered what makes chocolate cakes and cookies fluffy and soft? A white powder. We're all familiar with baking soda. When it reacts with acidic ingredients like chocolate, it forms bubbles to give that light, airy texture. But baking soda isn't just for baking. It can also help clean things around the house and make your teeth super clean and shiny when mixed with toothpaste. So it's pretty useful. But how is it made? Well, there are two main ways to get baking soda. In factory, scientists use a special multi-step process that combines common ingredients. First up, they use table salt to get the sodium needed for the reaction. Baking soda can also come from nature, less common but still cool. Some baking soda can actually be mined from the ground. Now, whether it's mined or made, baking soda needs a few other ingredients. Limestone provides calcium carbonate. Another key ingredient, carbon dioxide, also adds its special fizz to create the final product. And of course, water helps everything mix together smoothly. Most baking soda production relies on the salt process, also known as the ammonia soda process. This traditional method takes everyday things, table salt and limestone, and transforms them into something new, sodium carbonate, also known as soda ash. This soda ash is a crucial ingredient for baking soda. And guess what the sorbet process is responsible for? Creating about 3/4 of all the world's soda ash. The remaining quarter comes from a more surprising source. It's actually mined from the ground. The process starts with getting the ingredients just right first. They use purified water, heated to a specific temperature to ensure it's sparkling clean and free of any unwanted particles. Then industrial-grade salt gets carefully added to the hot water, but they stir continuously to make sure everything mixes evenly. The amount of salt is measured precisely to achieve the perfect concentration in the water, usually a percentage once all the salt is dissolved, making a saltwater solution called brine. They cool it down to a specific temperature. Now we have our saltwater or brine solution ready for the next steps. Now it's time for creating soda ash, also known as sodium carbonate. Remember that limestone we mentioned earlier? This rock gets mined and crushed into just the right size for the reaction. Then the brine solution we made earlier is the crushed limestone inside giant chambers called solvent towers. These towers are like high-tech pressure cookers, especially designed to handle scorching temperatures around 850 degrees Celsius or 1,560 degrees Fahrenheit. With all the ingredients in place and the heat cranked up, the limestone embrine solutions start to mix and a chemical reaction takes place. This reaction creates two things: sodium to carbon monoxide 3 dissolved in water. This is what we're after. We now have soda ash. The other product is calcium chloride to a byproduct. But don't underestimate this. Leftover calcium chloride has many uses. From de-icing roads in winter to controlling dust on unpaved surfaces. After the reaction in the sulfate towers, it's time for some cleanup. The mixture now contains our desired sodium carbonate dissolved in water, along with leftover calcium chloride bits. To get a clear soda ash solution, they put the mixture through a filtration process, like sifting flour. This step removes the solid calcium chloride bits, leaving behind a clean and sparkly sodium carbonate solution. Throughout this entire process, keeping a close eye on quality is crucial, ensuring everything turns out just right. The clean sodium carbonate solution gets another chance to react. This time, it joins a special tank with ammonia gas in brine. This mix creates two new products: ammonium chloride and sodium bicarbonate baking soda. There's also carbon dioxide in this reaction. This gas helps turn the sodium carbonate into solid particles of sodium bicarbonate, which settle at the bottom. These solid particles are then separated from the liquid, and voila, we have baking soda, ready for the final steps. If the leftover ammonium chloride doesn't go to waste, it gets used to make all sorts of things, from food products to helpful medicines. In the meantime, the sodium bicarbonate gets prepped. The sodium bicarbonate solution still contains other components and a fair amount of water. To get things right, they use a process called evaporation. Here they heat the solution, gently driving away the water and increasing the concentration of sodium bicarbonate. The less water there is, the easier it becomes for the sodium bicarbonate to form the tiny crystals we all recognize as baking soda. Remember how we reduce the water content? This plays a key role as the solution cools down. It gets stronger, and sodium bicarbonate doesn't dissolve well in cold temperatures. This is the cue for tiny crystals of baking soda forming in the liquid. Next, these precious crystals are separated from the remaining liquid using a filter or a special machine called a centrifuge. But the job's not done yet. To ensure the baking soda is sparkling clean and pure, they give the crystals a thorough washing, removing any leftover dirt or liquids. These steps of concentration and crystallization are essential for producing high-quality baking soda. It's all about achieving the perfect purity and the ideal size for those crystals. Those tiny crystals we isolated need to be dried off completely to remove any extra moisture. This makes sure the final product has that perfect dryness and free-flowing quality we all appreciate. For a quicker drying experience, especially in cooler temperatures, factories can use a vacuum chamber. The pressure inside the chamber is lower, which makes the water boil at a lower temperature. This allows the moisture to evaporate quickly without needing super high heat. In some cases, gentle heating in ovens or kilns might be used for drying. But this needs to be done very carefully because too much heat can damage the delicate baking soda crystals. Once formed, the crystals are passed through screens or seeds. These screens have holes that allow crystals of the right size to pass through, separating them from any larger or smaller ones that might not perform as well in baking. Another method uses targeted blasts of air to sort the crystals based on their weight. Lighter crystals get pushed farther, while the heavier ones stay put. This winnowing process helps ensure all the crystals are beautifully uniform in size, ready to become the perfect leavening agent in our baked goods. After the crystals are all the same size, they're ready to be packaged. Machines carefully pour the same sized crystals into plastic bags, ensuring the perfect amount goes into each one. With the help of computers, these bags are then sealed shut to keep the baking soda fresh. Depending on what the baking soda will be used for, it might be packaged in cardboard boxes, bags, or containers, no matter the final packaging. Strict quality control measures are in place throughout the entire manufacturing process. So there you have it. Baking soda's uses extend far beyond our homes, playing a role in industries worldwide. And if you enjoyed learning about how it's made, don't forget to like and subscribe for more insightful content. Thank you for watching.